Hello everyone, my name is Rosaura Vidal, and I will be presenting our work, Joint Visual-Temporal Embedding for Unsupervised Learning of Actions in Untrimmed Sequences. What is our motivation? For the task of action recognition, we need to know what specific action is happening at any given moment. But generating these labels can be very cost-intensive. So one would think, well, let's just train a network to do this. The problem is that this network would also require labels, which is something that we are trying to alleviate with our approach. So what we propose is an unsupervised model that receives as an input a given video and however many actions we want to identify in the video, and then it will return as an output the temporal segmentation of these videos, which would identify the boundaries of each of the actions. And how do we do this? Well, we have a three-step segmentation pipeline. The first and perhaps most important step is the extraction of a joint visual and temporal embedding. In this step, we want to be able to understand not only the visual aspects of an action, that is, how does the action look like, but also we want to understand how will the action evolve over time and how does it relate to other actions in the video. That is, we want to understand the temporal aspects of this. Once we have extracted an embedding that encodes both of these pieces of information, then we should be able to just cluster these features using any given clustering algorithm. In this case, we used Gaussian mixture models. And then we just clean up the temporal segmentations that you obtain from the clustering algorithm results with a Viterbi decoding approach. So how do we extract this visual and temporal embedding? For this, we have two main elements in our architecture. We have a temporal embedding model and a visual embedding model. And we train them in two stages. In the first stage, we train them disjointly from each other. So the task of the temporal embedding model is given an input frame, predict the timestamp of that frame. And for the visual embedding model is given an input frame, predict 5 frames into the future. That is, if you have frame 0 as an input, then you want to predict how would frame 4 look like. Once we have trained them disjointly, then we join them into a GAN-like architecture. So we use our visual embedding model as a generator and our temporal embedding model as a discriminator. So the temporal embedding model would receive the predictions from the visual embedding model and identify the loss of any temporal coherence in them. Once we have this GAN architecture, then we just train it in an iterative fashion. That is, we iterate the training from the generator and the discriminator. And at the end, we use the embedding from the generator for our clustering algorithm. And these are some of the results that we obtained. These are results for videos from the breakfast actions dataset, which basically show tutorials on how to prepare certain breakfast items. And we can see that our approach was able to not only understand the visual aspects of how does an action look like, but also understand the temporal relationship and the temporal coherence of these actions. That is, for example, you cannot stir fry an egg if you haven't cracked the egg first, or you cannot fry a pancake if you haven't prepared the dough first. So our method is able to understand the relationship between the actions across the video. And here are some of the results that we obtained. This is on 2 datasets that have either good visual cues or a good temporal coherence. And we can see, in this case for breakfast actions, that our method is able to not only outperform the unsupervised approaches, but also perform competitively against weakly supervised approaches. And this was also the case for YouTube instructions, which is tutorials on different actions like giving CPR or changing the tire of a car. But what happens when we don't have this temporal coherence? We were expecting, when we don't have this visual and temporal coherence. This is the case for this dataset called 50 salads, and we wanted to see how our method would do in this scenario. We can see a performance drop for this dataset. However, even though we were not able to outperform any of the state-of-the-art, the performance drop was not that high, considering that none of the cues that our method requires, which are visual cues or a temporal coherence of the actions, were not present in this dataset. And well, if you have any questions, please come to our session. Thank you.